Hey Kim, I'm more than happy to help you out with this. So here's what we have: the cubed root of 16x times y cubed, all under the cube root symbol. And we're going to subtract that from y times the cubed root of 128x. So where the 2 comes from is we're looking at 16, and I have to think to myself, what's the biggest perfect cube that I could pull out of 16? And if you have no idea, like I did, I had literally no idea, what we can do is a factor tree or a prime factorization on that number 16. So basically the whole idea here is like, give me any two numbers that would multiply to equal 16. I did 4 and 4. You could do 8 and 2 just as easy. Then I went right to 2. This 4 breaks down into 2 times 2. So does this 4, 2 times 2. So the equivalent way of writing 16 is really 2 times 2 times 2 times 2. Now that doesn't help us because we're looking for 3 numbers, right? The index here is 3. I have 4 numbers. So what I'm going to do is I'm just going to pick 3. That equals 8, and that's going to be my biggest perfect cube, right? Because the cube root of 8 is 2. Or the opposite, 2 cubed, 2 times 2 times 2 is going to equal 8. So that's how I can figure out that I can rewrite 16 as 8 times 2, where 8 is my biggest perfect cube. Now we're going to do the same thing over here with 128. Again, I had no idea. You could do it by 2's as well, like 2 times some number. You'll have a bigger factor tree. I went with 8 and 16, and then you know, like, oh yeah, okay, 8 is a perfect cube. There's an 8. 16 breaks down into another 8, 8 times 2. So what I can do is I can just take those two 8s and kind of multiply them together. Now you could rewrite this. I went 64. You could just as easily rewrite this as 8 times 8 times 2. You wouldn't be wrong at all. You're going to get the same answer. But here, because I know 8 is a perfect cube, 8 times 8 is 64. That's still going to be a perfect cube. So I can rewrite 128 as 64 times 2, which I did right over here. Don't forget your x. A lot of people do. X is still there. Then we can evaluate all this. So 8 is a perfect cube. I can evaluate that. The cubed root of 8 is 2, because again, 2 times 2 times 2 is 8. So that kind of comes out of the radical sign. It comes out to the left. Not a perfect cube, not a perfect cube, but y cubed is. Any variable with an exponent that is the same as the index, we can take that out, and basically the exponent and the index will cancel. So the y comes out, and then literally everything else just gets left underneath that cube root symbol. So the 2x, that's where that comes from right there. Over here, we have a y outside, so any number, any perfect squares that we evaluate, or perfect cubes, they're going to come out and get multiplied by that number. So the cube root of 64 is 4, because 4 times 4 times 4 is 64. The 2 and the x still stay there, so we're going to have a negative 4y times the cube root of 2x. And the last little bit here, because we have like roots, we have the exact same thing underneath the square or cubed in this example, the cube root symbol. That means we can add or subtract, whatever the situation calls for, the coefficients. The coefficients are the little numbers out here in front. So basically it's like 2y minus 4y. Well, that gives us minus 2y. And then the like root just comes along, the cube root of 2x. So that's going to be our final answer. Bit of an in-depth on that one, Kim, but I hope it helps. Let me know if it doesn't, and keep those great questions coming.